Okay, good afternoon, everyone. So, if you can remember last lecture, we talked about the Earth's atmosphere, right? If you can remember. Any questions on this topic? Any questions on this topic? Anyone? Any questions on last whatever we taught? Hello, can you hear me? Can somebody confirm that you can hear me?
Yes, sir.
Yes, sir.
Okay. All right. So if there is no question, so we can go forward for Earth's atmosphere. Okay. So you see the left figure, already I talked about it last lecture on Monday, that the Earth can be divided, or Earth atmosphere, it should be precise, Earth's atmosphere can be divided into several layers: troposphere, stratosphere, mesosphere, thermosphere, based on temperature. Okay, how the temperature behaves. Okay, and you see beyond certain altitude, the temperature almost like constant. Okay. And of course, if it is beyond Earth atmosphere, then temperature again will decrease and it will be interplanetary temperature. That is a different thing. But I'm talking about within Earth atmosphere, right? So now what happens? These there are, like in the thermosphere, mostly you can see the radiation from sun, mostly that high energy radiation from sun, they absorbed. Mostly they are absorbed. Like some portion of gamma rays, then X-ray, extreme ultraviolet. So those have energy, a lot of energy. Like in terms of, if you say EV, they have like more than like 7 EV or 10 EV, even KEV. X-ray has a KEV level, right? So these are basically all are absorbed in the thermosphere. Now thing is, if it is absorbed, they have so much of energy that they can not only dissociate molecules, they can also knock out electrons from the molecules and atoms. All right. So they have that much of energy with them. So of course it depends on the ionization potential. So obviously, if the ionization potential is of any atom is something like let us say 10 electron volt. So if it is more than 10 electron volt, so what will happen? It will be ionized, right? So that's how these atoms and molecules in the thermosphere, they becomes ionized. So they become ions and of course electrons in the daytime. All right, and that is the reason these are a region. Mostly this region is called ionospheric region as well. All right, and these ions, electrons, and of course there are neutral as well. So these are all together. These are called plasma. So plasma basically nothing else, nothing but ions, electrons, and mostly neutrons. So only less than 1% of thermosphere region is ionized. Other 99% is neutral actually. Okay, so you have to remember that if there is a question that how much percentage is ionized in the thermosphere, it is just 1%. So 1% of total neutrals, neutral atoms and electrons, neutral gas basically, is ionized. So it is basically ionized gas. Only 1% of the total neutrons. Baki 99% are all neutral, in remains neutral actually. All right. So you have to remember that, okay, the number. Okay. Now these are called plasma. Plasma means nothing but electrons, ions, and neutrons. So all the three together, they are called plasma. Okay. So plasma has certain properties. I'm not going into the detail. But why do you call it plasma? And I'm not going into the part. Okay. So it is not necessarily, I'm telling you, not necessary that ionized gas will be called plasma. Okay. So plasma, in order to tell that this ionized gas is plasma, they have to satisfy some properties. Okay. So in general, for your time being, because you are a first year student anyway, so I mean you just realize this is plasma. I'm not going into the detail what are the specific properties of plasma. There are 3-4 properties of plasma in order to qualify the ionized gas to be called as a plasma. Okay, so I'm not going into the details. So you will just realize that this is plasma is there. Okay, and there is a peak here. You see the density, and you can see the density. So daytime, nighttime densities are always there here. So based on the plasma density and plasma, basically plasma properties, I should say, this portion, the whole ionosphere, okay, this is called ionosphere because there's ions and electrons. The whole ionosphere region can be divided into 3 layers. You can see D layer, then E layer, and the F layer. All D region, E region, and F region, whatever you call it. And then F region can be has 2 peak, F1 peak and F2 peak. Why? Forget about for the time being. There are a lot of complex things are happening, so I'm not going into the detail part of it. All right. So now this based on the properties of the plasma, as I told, it can be just like in neutral things, neutral temperature. Temperature, the way the temperature decreases with altitude or changes with altitude, we have the troposphere, stratosphere, mesosphere, and thermosphere region, right? So in a similar way, the ionosphere region, which expand from like 60 kilometers through like 1,000 or more than 2,000, few thousands of kilometers, this region actually, it can be divided based on the plasma properties. Okay, so the first region, which is like almost like from 60 to 80, okay, this region 60 to 80, this region is called D region. Okay, so D region. So the D region has a lot of complex ions. Like complex ion means in the terms of like there are the compound ions, you can call it. Like it may have sodium bicarbonate plus or sodium bicarbonate minus, something like this kind of ions. So not only complex ion positive ions, it also has negative ions as well. So there is a lot of, so for example, it is a CO2, CO2H2O, something like that bond, it has a minus. Okay? So this type of complex systems, complex ions. Okay? And the densities are really low. Okay? The D region, the densities are very low. And in the night time, since there is no production in the night time, because daytime sun's electromagnetic waves are coming and they are producing. But at the night time, there is no sun. There is a high chance that they can recombine, okay, and becomes neutral. Okay, so the night time, when there is a sunset, they quickly recombine this region, the D region, and immediately vanish. Within hour of sunset, the D region vanishes. Okay. Any questions? All right. So again, I'm telling that the D region, it has a complex ions, negative ions as well, right? So not only positive ions, positive complex ions, it has a negative ions as well. Okay? And because since in the daytime, there is a production, and of course there is a loss process as well. So there are 3 types of process going on in the daytime. One is the production things that because of sun's radiations, these ions and electrons keep on producing, and there is a loss process via recombinations. So although they immediately produce, they try to recombine as well. Okay, so the recombination process is also there. Okay, and apart from recombination, so we have also transport process as well. Means it goes from one place to another, and they can have some other things as well. Okay? So there are 3 types of things available in the daytime. In the nighttime, production is 0, only recombinations and transport. Okay? So since the production is 0, and the daytime, what happens in the D region in the nighttime, it just after sunset, hours just after 1 hour, like maybe not only even few hours, it is just an hour before after sunset, D region, all the ions very quickly recombines with each other and become neutral, and D region completely vanishes just after sunset. Okay? But in the E region, there is another called E region. Okay? The density is quite more than D region. they have primarily molecular ions, which is called molecular plus, positive ions, NO plus and O2 plus, primarily NO plus and O2 plus. Okay, in the E region. Okay, so in the E region, molecular ion exists. Okay, so in the D region, what happens? All this complex ion exists. Negative complex ion, positive complex ion, all sort of ions, complex ion exist. It is a long molecular chain. They exist. But in the E region, only molecular ion exists, which is NO plus and O2 plus primarily. They have other ions as well, but dominant ions are NO plus and O2 plus. All right, and they have a relatively longer lifetime. That means after sunset, they can exist. They can sustain for a long time, at least several hours. Sometimes you say, the density, of course, it decreases because like a few hours, and they have some other ions as well. So in density, it reduces significantly. Okay, order of magnitude that reduces, but still it doesn't vanish. It is still there. You see, almost like 10 to the power 3, 10 to the power 4 order per cc. Okay, so they still exist in the E region after sunset, or in the night time. Still E region exists, but the density decreases significantly. Okay, you see, from 10 to the power 5 to 10 to the power 3 or even less sometimes. Okay, so E region exists, but drastically reduces, but doesn't diminishes. So like D region, the night time, they completely vanished, but in the E region, it doesn't vanish, but the density decreases significantly. Okay, and in the F region, there is another thing. Is F region is the density is the peak will be in the F region. Actually, it has a quite number density was quite a big, and they have only atomic ions because it is quite above it. So the peak is something like 350 kilometers over here. So beyond 120 kilometers, it is called F region. So the D region is 60 to 80 typically, then 80 to 120 E region, and beyond 120 it is called F region, and it is a peak in the F region itself there. And the main dominant ions are atomic ions, mostly O plus, then H plus, all sort of lighter ions will be there. Okay, so in the F region there will be only lighter ions, means atomic ions. The molecular ion no longer can exist because these are heavy. They are most found in the E region itself. Alright, and if you go up and up, you will find only H plus, only hydrogen ion. That's it, H plus, nothing else. You cannot get beyond certain. When no more other ions can be formed. So only H plus ions are there. Alright. Okay. So in the F region, you see that since only atomic ion exists and they have a very, very longer lifetime, several hours to half a day or something like that. So that is the reason, even if after sunset, in the night time, even after midnight, still the density exists. It doesn't vanish actually. The F region doesn't vanish at all. The density decreases, of course, but still it is quite significant density in the night time itself. In the night time also, it has a significant density. Okay, so since normally what happens in the night time in the equatorial region, so sun comes after almost like on an average after 12 hours it comes, right? So by the time this density they remains, the recombination rate are not that fast. Okay, and the density still remains it can maintain the density. And if of course if somehow it happens that the sun it doesn't see the sun for like few days, then of course the ionosphere will diminish. That is for sure. But still, since it is only doesn't see for like 12 hours, so it can still maintain it. And again after sunrise, again there is a production, and quickly it can rise. The density of plasma again goes up. All right, and beyond F region peak, the density that falls like this, and eventually after several thousands of kilometers, the density of plasma, it reaches in the interplanetary distance. I mean interplanetary, you can call it the density, and you can call it, it is no longer belongs to Earth atmosphere. All right. Any questions? Okay. So now you can, one question you can get, we can see, I mean you can ask that why we read this ionosphere first of all, at first place. Why there is a need for studying things? Why there is a need for research? Okay. And very important thing is, yes, it is useful for human day-to-day life actually. Okay. So the reason is long, like several years, thousands of years, I mean several decades ago, almost like 100 years you can call it, the time, I mean, or you can call it not your time probably. So before this DTH things or cable things, okay, you used to have Doordarshan, if you can, I mean many of you can, you know it, right? So before all sort of ZTV, Star TV, this only thing in India was Doordarshan, and there is no satellite televisions as well, right? There's only Yagi antenna used to be there in every household in the rooftop, and there is one TV. That's it. Okay. So these type of signals, they used to transmit from one place to another. Okay. So there is one place to another, they used to transmit. So there is a transmitter here, and there is a receiver here. Okay. So let me record 1 minute, 1 minute. Let me open this on Notepad. Okay. Or I'll use it. Wait a minute. Wait a minute. Okay, so let me share again one thing. Okay. So in those days, even I have seen that the ionosphere was used to be a mode of utilizations of communication signal. I mean communication things. Okay. So let us say this is Earth's surface. Earth's surface is a curved. Okay. And then let us say this is an antenna. Okay. Okay. And we have the antenna means there's a tower. Okay. There is a huge tower, just like a mobile tower, right? And we have here, we are there. Okay. And you see, if since Earth's surface is a curved, like this curved, right? So, and I mean the signal, it may not reach like this because it will, Earth will be, the surface will be this thing, it will be blocking it. But luckily we have ionosphere, ions. So it acts as a natural reflector of radio waves. Okay. So what it does, instead of seeing directly, they is to send to the sky all the radio waves, and it is bounced from the ionosphere and reached us. So the ionosphere will be used as a natural reflector those days. Okay, all that like intercontinental telegram, like from transatlantic, from Europe to America, that time they used to send telegram that time, like almost like 100 years ago, during First World War, even before Second World War as well. They used to send telegrams. That time it was not, phone call was not possible, right? The telegram message, the coded message, they used to send from Europe to America, the east coast of America, transatlantic things. So they used to send like that. Okay, so they used to send through ionosphere only. So direct communication is not possible. If it is nearby, then yes, receiver and transmitter. If it is nearby, then direct communication is possible. But since Earth is a the sphere, so this is the curved things, so it is not possible. So that is the reason that ionosphere things are very useful. Alright, so studying of ionosphere is useful, but there is another problem as well. So this is a natural ions, natural reflector, so it doesn't stay as like this. Okay, so in the night time they come a little bit down here. Okay, and in the daytime they goes up a little bit, and sometimes there are irregularities in the ionosphere. So some frequency may not be reflecting. So these all sort of things are very important things. And sometimes you see that nowadays all the satellites, they are top in the region in ionosphere, beyond ionosphere, like all sort of communication satellite nowadays. So they do the reflector part nowadays. They have an artificial reflector. They have an antenna like that, pointing towards Earth. Okay, like this. So nowadays what happens? They send not to ionosphere, because they send to the satellite, and this satellite has a reflector, and they reflect back to us. So all sort of nowadays that televisions, the DTH basically, all sort of things you are seeing at home, right? Tata Sky, Airtel, or all sort of things. So these are basically all are that instead of ionosphere we have a satellite here, and that have a huge antenna, and they act as a artificial reflector. So they send it absorbs from the antenna. They go to over here, and they radiate throughout the parts of the world, or parts of the particular parts in India or any places. Okay, but this signal of course travels through ionosphere, and sometimes if there is a irregularities, this signals actually has a problems. Okay, they cannot pass through it. So this process is, knowing this process is very important. All right, so that is reason the study of this kind of things becomes inevitable. Okay, so any questions so far? Any questions? Any questions? All right. So if there's no questions, so what are we now going to see? That again, just what I told, that the radiation, the electromagnetic radiations from the sun, they actually are responsible for producing the plasma in the Earth's ionosphere. Okay, so it has a plasma. Only 1% of the whole ionospheric or thermosphere region is ionized. Only just 1%, even less than 1% in fact. Okay, and it has 3 layers based on the plasma property. What are the properties? I'm not going into the details. So based on the plasma properties, this can be divided into 3 layers: D region, E region, and F region. Okay, so in the D region is a lower region. It extends from 60 to 80, mostly 80 kilometers. And in the D region, the complex ions, D for Delhi actually. Okay, so D for Delhi. So these complex ions, negative ions are there, and just after sunset, they quickly recombine. The recombination rate is very, very low, very, very high. Sorry, very, very high. The lifetime of these ions are very, very low. Okay, so that is the reason that just right after sunset, they quickly recombines and this D region completely vanishes in the night time. In the twilight time, there may be there, but in the night time, it completely vanishes. After evening, it completely vanishes. Okay. So beyond the D region, there is the region is called E region, and the E region it is from 80 to 120 kilometers region. This is called E region. In the E region, mostly NO plus, NO means nitric oxide, NO plus and O2 plus exist. Dominant ions are NO plus and O2 plus. Okay. So they exist in the E region. Oxygen ions means oxygen molecular ions, O2 plus and NO plus, nitric oxide. Okay. So this exists in the E region. And beyond that, it's called F region. And anyway, E region, what happens? The molecular ions has they have, I mean, they can exist even if after sunset, but they have also recombines. So after sunset or in the night time, the density drastically reduces in the E region. It doesn't vanishes, but it drastically reduces. Okay. And beyond F region, beyond E region, that is beyond 120 kilometers, we call F region. And this F region has only atomic ions, and the dominant ions is O plus, atomic oxygen plus, O plus, okay, atomic oxygen ion. And beyond F region peak, beyond certain region, it's called this plasma sphere, you can call it, or protonosphere, you can call it. It's only H plus ions are there, means protons, nothing else. Okay, so only protonosphere is called, and this H plus ions are there. So the F region, it has mostly, as I told, it is O plus, means the oxygen atomic ions are there, and even if in the night time, the recombination rate is very, very slow in the F region. Okay, and it still maintains that its density, although it reduces a bit in the night time, but still it can maintain it. Okay, quite a bit. So it doesn't reduces that much. Of course, it does reduce, but not reduces that much like E region, and D region anyway, it just vanishes in the night time. All right, any questions? All right. So now you see, together you see that neutral gas and ionized gas, the reason we are alive, or in the earth, what happens, because of earth atmosphere, neutral atmosphere and ionosphere, the life actually began. I mean, it started evolve. Okay. Otherwise, all the harmful radiations from sun, not only radiations, particle radiations and electromagnetic radiations, would have not let the life to form in the earth if there is no atmosphere of earth. If there is no atmosphere of earth, the life would have not begun actually. Okay, so, and at the same time, since earth core is a dynamic, so that produces stable magnetic field, and the magnetic field together with magnetic field with ionized gas or ions or plasma, it even more protects all sort of high energetic particles, high energetic ions and electrons, or I should say high energetic particles from sun, from reaching to the earth's surface. Okay, they protect us. So the whole atmosphere, they protect from electromagnetic radiations, all the X-rays, gamma rays, ultraviolet rays, they cannot reach the Earth's surface because of Earth's atmosphere, neutral gas. And for the ionized gas, what they do, together with Earth's magnetic field, all the particles, all the ionized or high energy particles, plasma, high energy plasma from the sun all the time, eject some sort of high energy particles. They cannot reach Earth's surface because of Earth's magnetic field, but they can reach Earth's surface via in the high latitude. Okay, so I'll show you one movie today. Okay, and let us even it will be more clear to you. So let me unshare it. So I'll give you the YouTube link as well of this movie, but right now I'll show you. Well, even it will be more clear to you. Where is that? Oh yes. Okay. Can you see that? This one?
Yes, sir.
Yes, sir.
Yes,
Okay.
yes.
So now what I do, I'll play it. Okay. Can you hear it?
Yes, sir.
Okay.
Sir, I think the audio is not coming.
Yes.
The audio of video is not coming. The video you are just showing.
Not coming? Anyone?
I have confirmed it. Video.
Not coming?
No, sir. No.
No.
Not coming?
Yes, sir. It's
No,
not
sir.
coming.
Okay, now you see? Coming?
I don't think so. Sir, can you play it once?
Okay.
No.
No?
No, sir.
But I'm
There's an
okay.
option, I think, of share sound, something like that.
Yes, when when you click on the share content button, it would have an option of including computer sound. I think you forgot to check that.
Okay, so what is that? Share computer sound.
Yes, sir. If you click on the share content button, it would have an option to include computer sound on the top.
Okay. 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 Fine. Sorry for that. Okay. Now can you see that? Can you listen?
Yes, sir. Now it's fine.
On
Yes,
Arctic
sir.
nights, the aurora often flames across the winter sky. What is it, and where does it come from? This is where the tale of the aurora starts. On the Sun, a star of average size among billions of other stars in our Milky Way. The Sun acts as an enormous power plant. The energy is created deep inside the core of the Sun. Here the temperature is over 14 million degrees, and the pressure so enormous that hydrogen atoms are squeezed together into another element, helium. This nuclear reaction releases energy. The light radiates outward from the core of the Sun. In the outer layers, the heat moves to the surface in huge eddies called convection cells. These electrical currents of charged gas create magnetic fields inside the Sun. In some places, strong magnetic fields push their way up through the surface. They slow down the eddies of hot gas. the surface cools, and darker sunspots appear. The electrically charged gas is called plasma. The plasma drags the magnetic field further outwards. The magnetic field stretches and twists like a rubber band, and then the rubber band breaks. Several billion tons of plasma is hurled out from the sun. This is called a solar storm. The solar storm can reach speeds over 8 million kilometers an hour. After 6 hours, it blows past the planet Mercury. After 12 hours, the planet Venus. And after 18 hours, the solar storm reaches Earth. When the solar storm reaches our planet, something strange happens. An invisible shield, the Earth's magnetic field, deflects the storm. The magnetic fields couple together and create a funnel where the gas streams down on the daylight side of the pole. This is the daylight aurora. The magnetic fields stretch further back and couple together. The magnetic rubber band breaks, and gas from the solar storm streams along the magnetic lines towards the poles on the night side. This is the nighttime aurora.
All right. So can somebody tell me what did you learn from here? So anyway, I'll share the link in the YouTube. Yeah, tell me.
The solar storms come from sun, and they get deflected. In 18 hours, they reach the Earth, and they get deflected due to Earth's magnetic field, because of which the stream currents go towards the north and south pole, and they appear in the form of aurora lights.
Aurora. So basically what happens in the low latitude region, it directly cannot enter actually. It enters in the high latitude pole side, both in the Arctic and in Antarctic region. Okay, so that is the reason you see when people say that those people have like the flight attendants who flies transatlantic flights. So they go via Greenland and everything, right? So they get a lot of doses of high radiations. So they, after sometimes their health checkup should be necessary because they go a lot of times. And those who stay in the high latitudes, high latitude, they also get a lot of dose of high energy particles. Okay. Now, what happens when these high energy particles they bombarded in the polar region? These neutral particles, they actually prohibits to enter. Okay? They are acting as a shield. So first shield is the Earth, that magnetic field. They actually cannot, the plasma, they cannot just like that enter. They only can enter through it. They produce a huge shield about it. It only enters through high latitudes region where the magnetic field lines opens up. And all the plasma they gyrate through the magnetic field lines and can enter through this through pole, Earth pole, either North Pole or South Pole, in both the region. Okay, And when they force throughout this altitude, the neutral particles, they also prohibit. Okay? And what happens? They collide with the neutral particles. And then since they have a huge amount of energy with them, these particles, mostly protons, sometimes electrons as well, they fight with neutral particles, mostly nitrogen and oxygen, because these are mostly dominant particles, right? Nitrogen and oxygen. 78% nitrogen, 21% oxygen. And depending on the energy of the high energy particles from the sun, they can create green aurora or red aurora or even blue aurora as well. In order to get the blue aurora, they have a lot of energy. They should have a lot of energy. Alright, so these type of auroras, so basically these are created because of nitrogen and oxygen molecules, okay, and atoms, all sort of things. Alright, so any questions? Any questions related to the whole topic? Just neutral gas, ionized gas, temperature, all the stratosphere, troposphere, stratosphere, mesosphere, thermosphere. Then basically beyond that it is exosphere, which I'm not talking about it. So here is a D region, E region, F region, then protosphere.
So where's the color coming from in the auroras?
Yes, the color means, you see, the green, if it is a green, so it depends actually what type of energy they came. So it depends, basically what happens, you know, that it knocks out one electron, right? Or it goes to a higher energy state of electrons, and they go to the ground state of atoms, on oxygen atoms or nitrogen atoms. So it depends on the energy. They again knock out, not only knock out actually, sometimes they forces this electron outer shell to go to a higher energy state. And when they come back, it forms an aurora, either in oxygen molecules or oxygen atoms. Oxygen atoms is not possible because it can knock out electrons from there. It depends on the energy, of course. But in the oxygen molecules, it is possible, this type of transition of energy state. Okay, so it goes to the high energy state because of knocking. It has a lot of energy to shift the electrons from a low energy state to a high energy state, and then again goes back to the original state. It forms a light. So these are called basically aurora. So green aurora, red aurora, blue aurora, also things are possible.
And sir,
Mm-hmm.
sir, how does those radio observatories work? Aren't the radio waves reflected by the ionosphere?
No, it depends on the frequency of the radio wave. So that is the reason I told. No? So at that time, during like First World War or even Second World War, the communication medium was like VHF, okay, or HF mostly. High frequency means it is 2 to 20 megahertz. So they actually can be reflected by the ionosphere. Okay. But if you send more than 25 megahertz or even 30 megahertz, the ionosphere cannot reflect it. It will penetrate through the ionosphere and goes to outer space. So during that time, what happened? Because of limitation of the technology, they could only produce like 10 megahertz, 20 megahertz, not more than that. Because of limitations of the system, I mean limitation of the technology. But nowadays we can produce almost anything, right? So we can produce gigahertz range. You see that 2G mobile, 3G mobile, 4G mobile, and now the 5G is coming. So 5G they can produce 50 gigahertz, and this 4G, these are basically like 2 gigahertz or something like that, or a little bit more than that probably. The S band that the Wi-Fi works, right? Wi-Fi works, dual Wi-Fi works in 2 regions nowadays. So one is the S band 2.4 gigahertz, and another is C band, that is 5 gigahertz. So these are actually penetrate through ionosphere. Okay. So all sort of the televisions nowadays, the satellite televisions, they work in C band or even more than that, K band, KU band, okay, or K band, okay, X band. But X band actually many things is not because they absorb, so the water vapor actually absorbs the X band. So many times it is avoided. The K band, KU band, V band, so all sort of things. This band actually they are used for satellite communications because they are not affected by the ionosphere. Okay? They are least affected. If you increase the frequency of the radio wave, they penetrate through it. Okay? But the L band, the GPS, the navigation signal, they are actually affected by, can be affected by L band, that 1.2 gigahertz, right? L1, L2, L5, all sort of things. They can be affected by ionosphere. And sometimes if there are a lot of irregularities in the ionosphere, these signals, they can be, has a problematic and they can give wrong coordinates, long latitude, longitude. Okay.
Okay, sir.
Okay, so I'll share another slide. Just a minute. Just 1 minute. Yes, let me share. Since you have asked the questions, so it is the best way is I should tell you about it. Okay. Can you see the slide?
Yes, sir.
Okay. So what happened? I'll give you one real life example. Okay. So this happens in if you go to the link, you will get to know. So you see, as I told that the ionosphere, like it affects, right? I mean, if there is a irregularities, there is, I mean, there are disturbances in the ionosphere, they can affect the radio signal in the GPS, that L band, 1.2 gigahertz. Okay. So one real life example happened. So what happened during the Afghanistan war, right? Then US fought with Afghan, like Taliban region, right? So what happened? One rescue mission was there, okay, to carry, like to take back wounded soldiers from particular region. So they have the coordinate. There is a helicopter, the big helicopter. I think Chinook or probably something else. So they used to, they had a lot of soldiers. They were going from going to a place where there are wounded soldiers were there. So they had to take the soldiers back to them, and they will go to a safe place. Okay, so they had a coordinate, latitude, longitude, and everything. Okay, but what happened when they, they went, they had a handheld device. Okay, that reads latitude, longitude. Every helicopter, every plane has, right? You know it. But what they did, sorry. So what they did, when they reached that place, okay, that particular locations in latitude, longitude, what they show, they see in their device, the Taliban actually, they blew it down. They gunned down the aircraft, the helicopter. Okay. So now thing came, what happened actually, because they knew the coordinate and they knew the intelligence report knew that there's a safe place, and the wounded soldiers told that no helicopter came there. Okay, so there is a lot of suspense happened that time, and this guy with the rescue missions, they told that no, we have been gunned down. Now we need rescue, something like that. Okay, and the wounded soldier, initially the wounded soldier, they told that no, nobody came to rescue. So they went to a different location actually. So what happened? You see, the ionosphere, that device, right? All the GPS signal, they rely on the ionospheric. They rely on the GPS signal from the GPS satellite. They are around the Earth in orbit, particular orbit, and they send signal, and they come through ionosphere. And if there is a irregularities present, then what happens? They produce a delay in the signal, and this delay causes error. So later on, after many years, after even after more than a decade or so, they realized that they had that particular region, the destination had a lot of issues with the plasma irregularities in the ionosphere. So what their system recorded, what their GPS device recorded, something else. Okay, so they actually wanted to go to a particular place, but they went to a different place, and their device their device showed that coordinate. Okay, so actually what happened, they read the wrong coordinate, although they showed it. Okay, let us say they wanted to go to 33 degree 22nd or something like that. Okay, but they were going to some other place, but still they're recording this 33 degrees, something like that, and the Taliban actually blew it. Okay, so that happened. So these L-band signals can also be scintillated or can also be affected by ionospheric phenomena. So that is the reason there are a lot of research actually now is going. There are a lot of fundings actually. There are a lot of opportunities in this field. So to study it so that we can predict this the whole process. But unfortunately, we cannot predict it. There are so many processes are going on. You cannot predict actually. All right. Any other questions? All right, so whatever I taught so far, so basic things. So in the exam that will be there. Okay, so these things will not be there. This is just for your kind of extra information only. Okay, so I'll give you only the basic things. So I hope you might have noted down. Right, so I'll give you only these things, or I'll just share the slides. Okay, that 2 slides. Okay, right away. Okay, any other questions? All right, so there is no other questions, so we can end the lecture today. All right, then in the exam we'll be there in the only the basic things, whatever I taught related to troposphere, stratosphere, all sort of things, and ionosphere. Only the basic things that I'll give in the exam. All right, then okay, then see you later. And in the next week, some other professor will take the class. All right.
Thank you, sir.
Okay. Yeah.
Yes, sir.